The lone pair of electrons will be present in equatorial positions. Here fluorine will have this. This is the most commonly appearing question in JEE. When 1 decimeter cube of CO2 gas is passed over hot coke, the volume of gaseous mixture of complete reaction at STP becomes 1.4. That means when you are having the CO2, Mendes reaction is used in catalytic hydrogenation of nitriles, whereas the first one is LAH. It is a versatile reagent. It is a very good hydride donor. It can produce many of the reductions. This is a methyl ketone and carbon when attached. It will produce an acid which contain 1 carbon less with strong oxidizing agents. Wanted to see you people scoring much higher marks, 600 and 650 plus marks, and getting success in all your examinations. Yeah, good evening guys. Hope you enjoyed the paper. And the NEET paper, when compared with last year, it looks like easy, but not that easy. It is taking some time. So this one is a good paper, and I would like to present the key, perfect key. And this is the question paper collected from one of the students. This is taken, and I am trying to explain the key immediately. So whatever the key presented over here, it is the best possible key and error-free key, I can say, right? So the first option, if you are looking at match the list with 1 with 2, the first compound is given as isopropyl benzene. It is getting converted into phenol. So the method itself, most of you are familiar. This is an example for, this is isopropyl benzene is cumene, and cumene hydroperoxide rearrangement. Here we are talking about the cumene hydroperoxide rearrangement is the question. In that what we do is, cumene will get oxidized by using an oxidizing agent. For that you can use atmospheric oxygen itself, and it will undergo hydrolytic rearrangement, and hence it will give rise to phenol. So the option A will match with this second one, and the second option is given as acetic acid. Acetic acid is getting converted into ethyl alcohol. Here one of the options, if you look at this methanol, when acid reacts with alcohol, that will give rise to ester. This acid will convert into ester first. This will get converted into methyl acetate with the first one. Then if you are using a hydrogen, right, once you get the ester subjected to hydrolysis, it will give rise to H plus, you are getting that ester, and then subjected to reduction. This reduction is carried out in presence of catalyst, thereby this acid will get converted into alcohol. And the third option, if you look at propan 1-ol is given, that should convert into propan 2-ol. So in that particular process, what we do is, we will first dehydrate that. That should get converted into this alkene. You will get that alkene. Subject that with the H plus water, that is catalytic hydration. This will always give rise to this propan 2-ol. So this C will match with this fourth option. So whenever you come across this kind of propan 1-ol dehydration product, then catalytic hydration gives rise to propan 2-ol. The last one is benzene getting converted into phenol. This is happening is oleum is used for sulfonation purpose. So first this benzene will get converted into benzene sulfonic acid. This one will get SO3H, and followed by sodium salt formation and H plus. This if you are using NaOH and H plus, this will get converted into phenol. So this D option will match with 1. So if you go by the correct option, if you look at A is matching with 4, A is matching with 2, B is matching with 3, and 2, 3, C is matching with 4. So you will go for this as the answer. So your answer will be 4. So if you go down to the next question, the major product Z formed in the following sequence of reaction, it is given. Ethane on chlorination in presence of sunlight, that will give rise to monochloro product. So here it is given as ethane, treat that with chlorine in presence of sunlight, that will give rise to ethyl chloride. Then it was treated with ammonia, it will give rise to ethyl amine or aminoethane. Then it is subjected to NaNO2 HCl. This is nothing but diazotization conditions. Since this is aliphatic primary amine, this will get converted into alcohol. If at all it is aromatic primary amine, it will get converted into diazonium salt. Aliphatic primary amine will get converted into this alcohols. So ethane, ethyl chloride, X is ethyl chloride, ammonia, this Y is ethyl amine, and Z is ethyl alcohol. So you will go for the second option. So whatever the question, if you look at, this is a basic level question where the students can easily answer it. I hope this can be classified as easy one when you talk about the paper. In qualitative analysis of bismuth 3 plus is detected by appearance of precipitate of bismuth oxyhydroxide. Calculate pH when the following equilibrium exists. Here in this equilibrium, this is a solid component and K value is given. So when K value is given, you need to write K is equal to active mass of products raised to their stoichiometric coefficients, BiO plus power 1 and OH minus power 1. And since it is a solid, active mass equal to 1 and its K value is given as 4 into 10 power minus 10. If at all you get this as X, this will also become X. That means OH minus concentration is equal to bismuth oxy ion, BiO plus, both are same. And if you take it as X, X square is equal to 4 into 10 power minus 10. You can write X as 2 into 10 power minus 5. So you got OH minus concentration as 2 into 10 power minus 5. Then take POH. This is nothing but minus of log OH minus. You can write minus of log 2 into 10 power minus 5 you will write. This is nothing but 5 minus log 2. Log 2 value is familiar to you, that is a 0.3010. Thereby this one will become 4.7 approximately. And if you take this pH, then 14 minus POH it will become 14 minus this 4.7. If you look at, this will be close to 9.3. So the probable mistake, once as soon as you get this one, you people, there is every chance that you may run down to this first option. And as we repeatedly say, whenever you get some easy question, if you get option 1 as the answer, it is a misleading option. So don't get carried away by the options, and the answer given for this will be 9.301. So all these three questions, if you look at, there is a possibility of error in this particular question. So I can classify this as a moderate, and you can take this as a trapping question where student can make a mistake. This is a simple concept in chemical equilibrium where everybody can know the theory, but the possibility of making error is more. If you look at this, when 1 decimeter cube of CO2 gas is passed over hot coke, the volume of gaseous mixture of complete reaction at STP becomes 1.4. That means when you are having the CO2, when it is treated with a red hot coke, that will act like a reducing agent and convert into carbon monoxide. So when you are having this 1 decimeter cube, 1 liter, initially this is 0. And after complete reaction at STP becomes 1.4. Assume that X amount of this carbon dioxide has been converted. Thereby, this will become 1 minus X. This one will give rise to 2X. That implies the total volume of the mixture, if you take it, this is 1 minus X plus 2X, which is equal to 1.4 it is given. That means X value is nothing but 0.4. So from this carbon dioxide remaining will become 1 minus x, 0.4, that is 0.6. And carbon monoxide formed will be 2 into 0.4, this will become 0.8. So you need to be careful that carbon monoxide is 0.8 and carbon dioxide is 0.6. Generally what people think is, they will ask you the amount of say this carbon dioxide and they may be going wrong. You need to choose the options carefully, what that fellow is asking and what we have identified. So based on that, if you look at this, 0.8 will be carbon monoxide formed and 0.6 will be carbon dioxide remaining, and hence you need to go by this. So if you see the next question, here it is the simplest question. In the entire paper, this I can say it as the easiest question, where the possibility of error is also very less. When n is equal to 2, L is equal to 1, n equal to 2, L equal to 1 will corresponds to this kind of 2p sublevel. If at all n is equal to 4, L equal to 0, thus corresponds to 4s level. And n equal to 5 and L equal to 3, this corresponds to 5f level. Because 0 is for S, 1 is for P, and 2 is for D, and 3 is for F. The other one is given as 3 and 2, so this is 3D. So if you look at that, this A option should match with 2P, that is the second option. B should match with 4S, that is the third. And C should match with 5F, and that 5F is 4, and hence 2, 3, 4, 1, the answer will become 1. If at all, in a hurry, if anybody makes a mistake, their rank potential will be greatly affected, because this is the easiest question in the entire paper. If you look at the number of chlorine atoms present in the organic product X and Y of the following, benzene is treated with chlorine in presence of this AlCl3. Whenever we are using AlCl3, the purpose of adding AlCl3 is to generate this kind of electrophile in a reaction, AlCl4 minus, and it will produce Cl plus. That implies this is an example for electrophilic aromatic substitution, where extensive halogenation it is given, polyhalogenation is it given, polyhalogenation is it given. So we need to go for, when excess of chlorine is there, you will get a hexachloro. All chlorines will get substituted. You will get hexachlorobenzene you will get. If at all it is chlorine in presence of UV light, or you can use the word HNU, sunlight, what will happen is this, what will happen when you are having a polyhalogen, this chlorination, Asian product will take place. Thereby, it will give rise to complete chlorination. So you will get this as hydrogen chlorine. Here you will get hydrogen chlorine. Here you will get hydrogen chlorine, hydrogen chlorine, hydrogen chlorine. In this manner you will get. Right? That means this will give rise to polychlorination. But the product is not benzene derivative. It is a derivative of cyclohexane, and hence you will get C6H6Cl6. So what we are saying is X and Y, the number of chlorine atoms present in the organic products X and Y. Here all 6 chlorines are substituting benzene ring, whereas here all 6 chlorines are substituting cyclohexane. This is what you call it as BHC, gamaxine, linden, which is used as insecticide. And hence you need to go for the option, this 2, that is the correct option. So here there is a possibility of overthinking and making a mistake, because chlorine, you will think this kind of polyhalogenation, can it happen or not? Chlorine is a deactivating group. Once one chlorine comes, it will get deactivated, another much deactivated. So your thought process may come like that. But here they want to test you only this AlCl3 will facilitate the reaction to be driven in electrophilic manner. Yeah. So you may think chlorine is a orthopara director again, and because of that reason, some of you may think of it as a 3 option, but the answer is 6. Suppose you are having in the following sequence X and Z respectively, ethyl alcohol treated with PCl5. This is a direct substitution product. You will get ethyl chloride and other product will become POCl3. And you are using alcoholic KOH. Once you get this, here you are getting CH3, CH2, Cl. This is treated with alcoholic KOH. Dehydrohalogenation takes place and it will give rise to alkene. And the compound given is, this is a peroxide. So whenever you come across a peroxide and treat that with HBr, only in presence of HBr peroxide effect will operate. Because of that, the reaction will proceed via free radical mechanism and you will get 1-bromo. So this is what you are calling it as a peroxide effect. This is also called Karash effect, which will be observed only in presence of HBr. Either with HCl or HI, this will proceed by ionic mechanism only. Otherwise, it will go by free radical mechanism and give this product. And here, if you look at this X, that X is nothing but POCl3 and other product will be HCl. This is a celebrated reaction in preparation of alkyl halides. So, if at all you ignore this or in a hurry if you miss it out, so you will directly go for it is a simple alkene treated with a HBr, reaction takes place and you will follow Markovnikov rule and first option is waiting for you. So again a trap, and hence I can classify this as a moderate type of reaction where students can make a mistake. So need to be careful, and hence here your X will become POCl3 and the product, final product Z, if you look at 1-bromo, and hence you need to go for 4th option. So if you look at these 7 questions so far, all the questions look to be simple, but every question has a trap. Everybody feels that, yes, I did well. But after seeing the key, there is a possibility of losing the marks. So whoever is cautious, whoever is attentive and do the paper with a cool mind, they will only get success. This one is vanadium pentoxide. This is the most commonly used catalyst in contact process. That is preparation of H2SO4 from SO2. So this one will match with this. And iron is used as catalyst in Haber process, Haber-Bosch process, where ammonia is prepared. This is matching with 1. If you take palladium chloride, this is used in Walker's oxidation in order to convert ethene to this acetaldehyde, and propene to acetone. We will use this palladium chloride. And in nickel complex, we use it in polymerization of the complexes. So if you see this one, since you people are very much familiar with Haber's process, contact process, and this palladium, so you can easily mark the answer. So it is one of the easiest questions, I can say. I may not grade it as the easiest. It is easy questions where nobody will make a mistake. If you look at the next one, this is the simplest one, ClF3 molecule. If you look at the chlorine, you can find the total number of electron pairs by using half into group number. Chlorine is the central atom. It is having a 7. And the number of monovalent atoms attached, it is 3. Since it is not a charged species, we don't have any further gain of electrons. So total number of electron pairs are becoming 5, out of which chlorine is forming 3 bonds with fluorine, and hence there are 3 bond pairs and 2 lone pairs. So as per VSEPR theory, if you look at the shape of the molecule, or geometry will become trigonal bipyramid, whereas the shape of the species will become this T shape, where the lone pair of electrons will be present in equatorial positions. Here fluorine will have this This is the most commonly appearing question in JEE, where the number of 90-degree bond angles will take it as 0 because of that repulsions. So if at all you are having this, it is having a T shape with two lone pairs of electrons occupying equatorial positions. So it has a T-shaped geometry it is given. It is having a what type with two lone pairs on chlorine atom. So you need to go for option 2 only. Actually, we should use the word trigonal bipyramid geometry with two lone pairs occupying equatorial position. Shape is T. So since he has mentioned T-shaped, shape is T. So it has a trigonal bipyramidal geometry with two lone pairs on chlorine atoms. So there is another possibility you may be thinking. So here it is given as trigonal bipyramidal geometry with two lone pairs with chlorine atom. Since it is given as a pyramidal, don't get carried away by. Right? And also don't think that these atoms will lie in this manner and it will give rise to planar molecule. It is having the two lone pairs, right? It has two lone pairs and this is the correct structure, not this one, right? So it is not a pyramidal, it's a bipyramidal. So here also looks simple, but the trap is there. So this is also a moderate kind of question which we can grade it and need to be cautious. And if you look at calculate EMF of the half cell given below, platinum hydrogen at 2 atmosphere pressure, it is not 1 atmosphere, so it is not a standard hydrogen electrode. And the concentration of HCl it is given as 0.02 molar. That means both concentration as well as the pressure is changing. And be careful what he is asking. E0 of H2H plus. That means that fellow has given E0 of H2H plus. That means this reaction is oxidation. That means he has mentioned standard oxidation potential as 0. And once again he is asking potential of the half cell represented by this. General way of representing is H plus getting converted into hydrogen. But here the representation is given as hydrogen H plus, indicating that he is talking about oxidation potential. If you write a common reaction, this hydrogen gas will lose electrons and convert into H plus and 2 electrons. So if at all E is the potential of this half cell reaction and E naught is its standard, you can write it as E naught minus 0.059 by N, 2 electrons are involved, log of Q. In this Q, you are having a H plus concentration whole square by this gaseous species we are talking about, the pressure of hydrogen. Thereby this value is given as 0. So this is becoming, this one is taken as 0.059 by 2 log of H plus concentration, it is given as 2 into 10 power minus 2. So this is becoming 2 into 10 power minus 2 whole square. And this pressure of hydrogen, it is given as 2 atmosphere. Thereby, if you simplify this, the option will turn out to be 0.109 volts. There is every possibility that people will take this. But the correct answer is 0.109 volts. Because he is asking oxidation potential. He is not asking the reduction potential of the electrode. If he mentions reduction potential, as per IUPAC convention, we need to go for SRT. But here he is talking about oxidation. There is every chance for many of the students to go wrong. And even people may think, since it is given as H2, H plus, sometimes they may take double the answer or half the answer, forgetting that reduction potential is an intensive property. So there is every chance for making a mistake. It is a good question and I can grade it somewhat tricky and tough question only I can grade it. Because here the variables are two variables. Pressure is varying as well as concentration is varying. Most of the people got used to solve the questions by taking a concentration or pressure. When both are given, so they will feel it difficult. So this is a good question. And here it is a simple. It is the order of the reaction it is given. Whenever you are talking about the rate of a reaction, rate is equal to this rate constant into concentration of the reacting species power n. So most of the people, when you are talking about K, since it is a proportionality constant, they may not have units, but the reality is K equal to rate by concentration power n. So rate is expressed in terms of mole liter inverse. This is the second inverse rate divided by this concentration. You will express it in terms of mole per liter whole power n. So you can write the units of K that will depend on the order of the reaction. So while we are writing units of K, you need to see which order it is. So if at all you are having the zero order will have same units as that of rate of the reaction. Rate of the reaction means mole liter inverse second inverse. So your A will match with mole liter inverse second inverse. And the first order will match with the time inverse, that is second inverse. And hence, if you look at the second order, then it will become mole inverse liter second inverse. And obviously the other one will become this 2. So if you go by that, the option will be 3. It is also a simple question, I can say. It is not that difficult. This is the basics of chemical kinetics, and hence I can classify this question as easy question only. So if you go by this calculated spin only magnetic moment of titanium, if you look at the titanium, the atomic number of this element is 22, and if you write the electronic configuration, argon core, of course it is given, argon core, this one will become 4s2 and you will have 3d2. And after removing the 2 electrons, titanium 2 plus, it is given as 3d2. This is argon configuration will be there as it is. So there are 2 unpaired electrons. The spin only magnetic moment associated with it will become root n into n plus 2, where the units of this will be Bohr magnetons. So you are having this 2 into 2 plus 2, and hence it is root 8. Thereby 2 root 2 it will become, it is nothing but 2.84 Bohr magnetons. So this is also a simple formula application based question, which I can classify it as easy only. Because everything is given. Even you don't need to remember the atomic number of the element. You don't need to remember whether s electron is removed or d electron is removed. So directly that fellow has given D2 configuration, and hence it is the easiest question I can say. 2 products X and Y are formed in the following reaction sequence. Methyl chloride anhydrous AlCl3. This is an example for Friedel-Crafts reaction. You will get this methyl benzene as the product. So your first product W will be methyl chloride and methyl benzene, toluene. Dilute HNO3, H2SO4. This mixture you are calling it as a nitration mixture. And since this being a ortho-para-director, there is a possibility of getting 2 products. Here you are having this one, CH3 and NO2 group. And there is another possibility where you can get CH3 and NO2 here like this. Ortho and para products, which will differ in their boiling points. Because of that, if 2 substances are differing in the boiling points, then they can be separated by fractional distillation. So this is a fractional distillation. This is one of the examples that were quoted in NCERT book. So those whoever is following NCERT, then there is no question of making mistake. Being a biology student, having the mindset to follow NCERT line by line, nobody will make a mistake, and hence the answer will be this fractional distillation. This is also an easy question I can say, and directly lifted from NCERT. And if you look at a bulb is rated at 150 watt. So as soon as a numerical appear, that too with this kind of coefficients, the general tendency of student is, numerical it may take time and leave it. But this is the simplest question. 150 watt, what does it mean? It will emit 150 joules of energy per second. If at all it is 100% efficient. But he has mentioned 8% energy into light. Only 8%. So the amount of energy that is spread out, it is 150 into 8 divided by 100. 8%. Thereby this will become what? This is simply becoming 12. So the amount of energy what you are going per second is 12 joule per second only it is emitting out. And that energy is emitted in the form of radiations. And each radiation, he has given how much energy is there. Each radiation is having 4.42 into 10 power minus 19 is the amount of energy. Assume that n such photons are emitted out. So n into this is number of photons emitted per second. That will give you the amount of energy it is radiating. So if you go by the calculation, so 12 by 4.4, approximately it will become what? 2 point. And this 10 power 19, it will go up. So there is no need to worry about these two. This one is straightforward. So only thing is whether you have that bent of mind to solve the question, positive frame of mind towards the question. This is 150 watt given, 150 joule per second is the amount of energy it is radiating, but it is only 8% converted into light. That means 12 joules of energy. So each photon, if it is having an energy of 4.42 into 10 power minus 19, 12 joules energy if you want to contribute, you will get this and you can go by that. It is possibility of making error. 150 into 8, you may take it as 80 and take it as 120, or you will forget that completely and write 150 and calculate it. So there is a possibility of error. It is a good question. It is not that easy question to solve. I can say for NEET students it is difficult only. This is a straightforward one. The name itself is suggesting having the smell of vinegar. There is the matter. The acid that is named after vinegar is acetic acid, acetum, vinegar smell, and hence the correct anion among them is acetate ion. You can just go by this. Nothing else. Straightforward. Within 2-3 seconds you can get at the answer and save your time. Simplest one. Select the reagents that reduce nitriles to primary amines. This is a very good question. Here you are having a CN. CN should get converted into primary amine, that is RCH2NH2. Here you can use straight away LAH can do that. The first option, LAH can do that. SnHCl, that is a metal acid combination. People may get carried away because this is the option which we repeatedly see in almost all the reactions. Whenever we are talking about this kind, when you are having a nitrobenzene, that will get converted into aniline. There you will use diazotization, convert that into diazonium salt, and then further reactions. So as soon as people see SnHCl, this is the reagent which is there in the mind of the student for long period of time. So as soon as you see, this is a most familiar reagent, this should be the answer. This will never convert this cyanide to this kind of CH2NH2, that is a primary amine. So amine conversion, aliphatic amine conversion, nitriles to primary amines can happen. CN will get converted into NH2 by catalytic, that happens. That is what you are calling it as a Mendes reaction. Mendes reaction is used in catalytic hydrogenation of nitriles, whereas the first one is LAH, it is a versatile reagent. It is a very good hydride donor. It can produce many of the reductions. And don't get carried away, fooled by this SnHCl, because you are familiar with the reagent. Since you know it, it cannot be the answer. You should see what option is asking. Other one is sodium amalgam methyl alcohol. This is also very good trap. Even most of the people will think mercury is used to suppress the ability to act as reducing agent. Still, it is able to convert this nitrile to amines, which was given in your NCERT book. So it is a mandatory for everyone. Whoever wants to a good score in chemistry, it is a mandatory to go for NCERT book. NCERT is the Bible. And bromine NaOH, what it can do? It is no way going to convert that into amines. Thereby, you will go for A, C and D, and there is a possibility for maximum number of students making mistakes. So, it is difficult, I can say, and it is mandatory to go through NCERT reactions, otherwise you will fall. You will definitely go with one, no doubt about it. Identify the incorrect statement from the following. Carbon has the ability to form p-pi multiple bond with itself. This is one of the reasons why carbon forms so many compounds. Catenation tendency arises because it has a tendency to combine with its own elements. It has tendency to combine with other heteroatoms. So this is a correct statement, but it is asking incorrect. Until and unless if you don't mark it, our tendency is generally to find correct options. So as soon as you see first option, you will think this is the correct answer and you will mark it and you will lose 4 marks. So you need to read the question. When you read it, it is incorrect options and hence you need to go for. This is correct but not correct for this question. This is correct option but he is asking incorrect. And ECl3, E equal to B and AlCl3 is a monomer when E equal to B. Yes, boron trichloride is a monomer because it can satisfy its electron deficiency by back bonding. Whereas aluminum chloride, though it has that d-pi bond is not effective, back bond is not effective, and hence it will get dimerized, whereas this fellow will not. That means this is also a correct option, but not for this question. Oxygen exhibits only -2. It's a blunder. -2 only in oxides. If you take this peroxide, it will exhibit -1 oxidation state. If you take superoxide, O2 minus, it will exhibit -1/2 oxidation state. If at all it is combining with other element like OF2, it can show +2 also. If at all it is having O2F2, then it can exhibit +1. So this option is incorrect and it is the correct answer which you need to choose. The other one, the order of catenation property, as you are aware, as you move down, with increase in bond length, this strength of the bond will decrease and hence catenation tendency will also decrease. So this is good question. Inorganic question. People will fear of taking inorganic chemistry with a prefixed mind that it demands memory. No option demands memory. Every option you can think logically and answer the questions. So here also there is a possibility of making mistake. It is not that easy as it appears. It is easy when it is explained by the faculty member. It is not easy when you are writing the exam. That's why this I can write it as a moderately difficult question. Although +3 oxidation state is most common in lanthanoids, cerium will show +3 oxidation state. Hope you are familiar with this. Cerium is the first lanthanoid element. Because if you are having this cerium 58 to 71. And this is the element which comes before lanthanum. And the lanthanum is 57. And if at all it is losing that 4th electron also, it acquires 0 configuration, 4f0. This is also a straightforward question which people might be learning in anomalous configurations which we are saying along with the chromium and copper. So there is no question of making mistake and hence you need to go by this 4th. If you look at Lassen's test, the elements present in an organic compound are converted from organic compounds. This is a chemistry where carbon is involved, where covalent bonds are there. Whatever nitrogen is present, that will be converted into cyanide ion. Because it is ionic reactions are easy to carry and easy to identify the ions. So nitrogen part will convert into cyanide ion. Whereas halogens will be there, they will get converted into halide ion. Sulfur is present, that will get converted into sulfide ion. So there is every ion, there is a characteristic reaction which we can use it for detection purpose, and hence all the elements which are there in covalent compound form, they should be converted into ionic form, thereby their testing will become easy. And hence covalent form to ionic form will be the answer. So we will go for the third. Unless you think logical and act logical, then only you can identify it. If you just go by memory base, it's gone, and hence you can classify it as moderate. Be careful. If you look at the number of hydrogen atoms present in 5.4 grams of urea, first you should know what is the formula of urea. It is a NH2CONH2. So whenever you want to predict the number of hydrogen atoms, first predict the number of molecules present. To find that number of atoms is nothing but number of hydrogen atoms is nothing but number of moles, that is weight divided by gram molecular weight. Multiply that with Avogadro number, that gives you number of molecules, and multiply with how many hydrogens are there. There are 4 hydrogens per this. Thereby weight is given as 5.4 grams, so it is 5.4. Urea molecular weight is 60 into this Avogadro number, 6.02 into 10 power 23. You multiply that with 4. If you go by this, the calculation can be done very easily. So this is the fundamental question which you might have learned from 9th class itself. So there is no possibility of making mistake. So here you may think how many molecules are there. In that aspect it may be wrong, but you need to read the questions properly. Hydrogen atoms present. Each molecule of urea has 4 hydrogen atoms. So you need to be cautious. You need to be doing calculations properly. And hence, this is also a moderate level of question for NEET students, not easy question. The pair of molecules that are metamers. Metamers means the compounds which are differing in the nature of alkyl groups connected to a divalent molecule like ether, or divalent molecule like a secondary amine, like a divalent molecule like esters. We generally come across. So if you look at this, this is alcohol. The first 2 are examples for position isomers only. If you look at this, methyl group and propyl group is there. Here ethyl group and ethyl group. So these 2 compounds are having a divalent functional group like oxygen. They are differing in the nature of alkyl groups, and hence they are also examples for metamers. If you look at these 2, they are functional isomers, as you are aware. And if you are having this, they will differ in the length of the chain, and hence chain isomers. So you will just go for second. It is a somewhat easy level question only. This is not that difficult in organic chemistry to find out the metamers. Identify the incorrect. Once again, there is a possibility of error by not reading the question, so it is incorrect. This kind of questions, you should not waste much of the time. You should directly go by nitrogen you are talking about, and here you are coming across a d pi p pi. Nitrogen doesn't have d orbitals, there ends the matter. Close the answer by just taking it. Others, you don't even need to see. You can save the time and move on to the next question. Phenolphthalein is used as an indicator for the titration of sodium hydroxide solution against a standard solution of oxalic acid. As you are aware, here he is asking that is observed at an alkaline pH. At alkaline pH means the pH is greater than 7. And in that particular pH range, instead of looking at what I am taking it in burette, what I am taking it in conical flask, instead of thinking much, in this particular pH, what change you will find it in the indicator. Since phenolphthalein is an acid type of indicator, which is exhibiting strong color, intense colors in alkaline medium, which is nothing but pink, and in acidic medium, this is becoming colorless. Now he is asking in an alkaline pH close to the equivalence point. So since the pH maintained is in alkaline zone, that indicator will be exhibiting pink color. So earlier it is in colorless way, and hence you just go by colorless to pink. Here there is an ambiguity. Different people may interpret in different ways. Which one I will take it in burette, which one I will take it in conical flask. So discussion may go on. But by purely looking into the question, asking at the alkaline pH what is observed, we are going by this option. So there is a bit of ambiguity here. So you can take your performance in chemistry as a plus or minus 4. If you go for option 3, most probably you will get 4 marks. So if NTA thinks and many people think in different way, then there is a possibility saying that this will become pink to colorless. But based on the observations, our answer is 3, that is colorless to pink, purely based on the question given to you. Then this one is the simplest one, ethene C2H4. You are writing it as CH2 double bond CH2. Always you are familiar with. In a multiple bond, one bond is always a sigma, and the remaining are pi bonds. Thereby 2 here, 1 here, you will come across a 5 sigma and a 1 pi bond. In a similar way, C2H2, if you look at it, is a triple bond CH. It is having a 3 sigma and 2 pi bonds. If you are having a methane, outright you can say there are all 4 sigma bonds only. And if you are having ammonia, it is having a 3 bond pairs of electrons and 1 lone pair present. So if you look at this, this is a straightforward question which you can go for this option. With the first option itself, A gives 4, 5 sigma bonds and 1 pi bond. If you match it, there is no option which will match like that. So this is the way of saving time, right? Next, at certain temperature T Kelvin, during a process, 500 joules of energy is absorbed by the system, and the work of 200 joules is done by the system. The first law of thermodynamics says internal energy of the system can be enhanced by adding energy in the form of heat or by adding energy in the form of work. Work done by the system, you will take it as a negative as for IUPAC convention, and work done by the system, you will take it as heat given to the system, you will take it as a positive. So it is given to the system and this is work done by the system. This is the total change in internal energy. dQ, 500 joules is absorbed, it is taken by the system, plus dW, it is work done by the system 200 joules minus 200. Thereby dE value is nothing but 300. So you will just go by this option. This is also a primary question, fundamental question. If you make any mistake, your rank will be killed like anything. So sign convention is the most important. Since you people are very much interested doing physics, then there is every possibility that you can get the 700 joules if you go by physics convention, as far as work is concerned. Right? So this is a simple question, but people will make mistakes in simple things only. So need to be careful. Methane reacts with steam. This is a purely NCERT. Those whoever is vigilant, whoever listens to the words of the lecturers, instead of feeling, okay, we know everything. This question is very, very important. You will get CO and H2, that is water gas. So this is very, very important. NCERT based question. There is a possibility of error. I can say this is moderate. Memory based question. Until and unless you don't have good memory, there is every chance to falter. This one compound gives a red-orange precipitate with 2,4-DNP. Immediately it is given 2,4-DNP red-orange precipitate. Means there is a carbonyl group present in the molecule. And he also mentioned it does not reduce failing reagent. Question is over. Those which do not reduce a failing solution, that is nothing but a ketone. So whenever you come across C8H8O, The ratio between carbons and hydrogens is almost 1. You can imagine one benzene ring. So if you write that one benzene ring, you will get this as C6H5. Then 2,4-DNP positive test, carbonyl group is there. And at the same time, it does not produce a failing solution. Indicate that the carbonyl group present in it is a ketone. Thereby, you will write it as CO, CH3. It is nothing but acetophenone, and it satisfies the other conditions itself. So when it is oxidized, what will happen? This is a methyl ketone and carbon when attached. It will produce an acid which contain one carbon less with strong oxidizing agents, and hence the first compound is acetophenone and the next one is benzoic acid. You will just go for second option. So you will get this. This is a simple question, but there is a possibility of overthinking, and hence I can say people being over smart, they will lose the marks. Right? This is also NCERT question, which is there directly in the book. Right? Those who ever doing book, they will be getting. A solution of copper sulfate is alkalized for 10 minutes with a current of 1.5 amperes. So he has given T, he has given strength of the current. First predict what is Q, that is nothing but C into T, 1.5 amperes. Multiply that with 10 minutes, 10 into 60 seconds. And since we are dealing with the Faraday's laws, 1 Faraday of charge will always deposit 1 equivalent weight of the substance. 1 equivalent weight means it is 63 grams divided by 2 because it is a copper sulfate, and hence equivalent weight will become 31.5 grams. So thereby, if you are having 1 Faraday, it will deposit 31.5 grams. Generally, the atomic weight of copper, we used to take it as 63.5. This we will remember it as 31.75. Don't do your own calculations because that fellow has mentioned it is 63 grams. So we should take it as 31.5 for 1 Faraday. So you know how much is current has sent. This is this many coulombs. Convert that into Faraday, 96,500 coulombs. Will deposit how much? So it is a problem based on calculations where there is a possibility of making an error in doing the calculation, and 96,487. So here also there is a possibility of going wrong. Slight variation may come. So you need to take it as this. So it takes a lot of time to do the calculation. So it is a calculation error possibility is there. So I can brand this as a difficult as far as calculation is concerned. Yeah. This one also, minutes is given. You should convert that into seconds. Right? The functional group that can be identified through phthalene dye test. Straightforward. You can just go for phenols. Alcohols can be identified by CAN test. Aldehydes can be identified by 2,4-DNP. And carboxylic acids can be identified by NaHCO3, sodium bicarbonate test. So, straightforward test, easiest question and time-saving question. If you go by this correct statement regarding the secondary structure of DNA, you just go by biology people, there is no chance for making mistake. If you make the mistake, nobody can excuse. Good luck next time. If at all you miss it, you should not miss it. So it is having a DNA possesses a double helix structure, and thymine is one of them. And this you have been repeatedly shouting that a double helical structure, base pairing principle will operate. Always ATGC you will be writing. So this thymine will be present in DNA. So you need to be careful. And there should not be any error from biology student. A faculty who is teaching MPC and chemistry, he may make mistake, but the student should not make a mistake. If he makes a mistake, we are lucky, we will get one more admission for extended batches. Right? The correct statements regarding that. So if you look at this, first you try to solve the theoretical questions. Aquatic species are more comfortable in cold water. More comfortable in cold water because With increase in temperature, the solubility of gases in liquid will decrease, and hence in hot water, the amount of oxygen that is dissolved in water is less. Aquatic animals will not survive. That's why aquatic species are more comfortable in cold water is a correct statement. And he is also asking correct statements. Next, so you can have C. Outright you can remove what? You can remove 3 and 4 gone. Then comes the solubility of a gas increases with decrease in pressure. I hope you are familiar with Henry's law. With increase in pressure, the solubility of a gas will increase. That means this is an incorrect statement. So for our question, it won't be required. And for a binary mixture of A and B, the number of moles of A and B are Na and Nb. The mole fraction of B will be Xb equal to Na by N plus Nb. Here it is given as Xb, and here he is writing as Na. So this is also incorrect statement. So among this, A and C is one option, A, B and C is one option. Now we need to see B problem only. So if you are having a molarity of solution containing 5 gram of NaOH, 5 gram of NaOH means 5 divided by 40, that gives you a number of moles of that. And 450 ml of solution, he is talking about molarity, and hence volume in liter, that is 450 by 1000. If you do this molarity, you will get it. And that one is correct. So if this is correct, B and C involved option, you don't need to solve A, so you will go for second option. So this is a time taking, 2 problems you need to solve. That too having some calculation which you feel, most of you feel difficult, and hence this question I can grade it as difficult question. This is a simple, looks simple, but difficult only. So need to be careful. Mixture of chloroform and acetone forms a solution with a negative deviation. Hope you are familiar with. Here you are having a CH3CO. Before addition, they are having the dipole-dipole forces only. Chloroform is also non-polar. Dipole-dipole forces will operate. But once you add these two, there exist this kind of hydrogen bonding interactions. Because of the stronger interactions between AB, what will happen is tendency of these molecules go to vapor state, tendency of these molecules go to vapor state, both will get reduced, and hence the solutions will exhibit negative deviation. That means the formation of hydrogen bonding between acetone and chloroform will enhance the attractions. Thereby, you will go by this. This is simplest one. Most of the people will ask this question, might have answered millions of times, and hence this can be classified as easy, and you should not make any mistake. At 298 Kelvin, certain buffer solution contains equal concentrations of X minus and HX. That means weak acid is there, its a conjugate is there, and hence it is a question based on Henderson equation. You will write it as a pH as soon as you see that pKa of that acid plus log of salt, you can say conjugate base by acid HX. Remember, this is a trap. pKa of acid you need to take. But that fellow has given Kb for X minus. So when you are given Kb for X minus, he is given as 10 power minus 10. You should know Ka of this into Kb of this must be equal to 10 power minus 14 Kw. Thereby, this value is nothing but Kw, we can write 10 power minus 14. If you write this Ka, this is becoming 10 power minus 4, you will write pKa will become 4, and here it is given as log of salt as 1, and this also 1, equal concentrations, and hence pH value will become 4. You need to go for third option. So if you directly take this, then you will get 10, and that is the option there. You are gone. So unless you are thorough with what is the Ka value, what you are using there, and how to find Ka when Kb is given to you, you just need to go by that. So you will go by this. So this is a wrong answer, a trap answer. Trapping key. So need to be careful. So this also I can take it as a moderate question. because the calculation part is not that big. Only thing is you need to have an idea that Ka into Kb equal to Kw. Based on that, you need to do that. Identify the incorrect statement from the following. IUPAC name of the element with atomic number 107. This is un nil septium. That is correct, perfectly written. Largest and smallest species. Largest will be, in this case, magnesium, aluminum across the period. What will happen is atomic radius will decrease. Magnesium is the largest. And when you are having smallest, aluminum 3 plus. Right? So here he is talking about the largest and the smallest. Here he mentioned as aluminum and magnesium, but it should be magnesium and aluminum 3 plus. Thereby, this one is incorrect. Here also you need to be cautious while talking about wording. Wording is more important. Otherwise, there is nothing much in this to discuss also. Right. Because if you are reading it as correct, and first option is a trapping answer. So, easy to make errors also. It is easy to make error. The correct order of increasing metallic character. Alkali metals are highly electropositive, that you know. So, highest is for sodium. Next option is alkaline earth metal, that is magnesium. Sodium is present here, magnesium. So, this is gone. You can go for either this or this. After that, another, that is a beryllium, alkaline earth metal. You will just go by this. This is also an easy question. You can say periodic table. The correct IUPAC name of the following compound. Need to be careful. Here, don't number it in this manner, because here one more carbon is there. So you write it as 1, 2, 3, 4, 5, 6, 7. If you write this also 1, 2, 3, 4, 5. So alkyl groups are getting identical positions. Need to be careful. Wherever the alphabetical that comes first, that should be given lowest number. Thereby, third position you are having a ethyl group, you need to write. And the fifth position it is having a methyl group. And as you are aware, long chain is made up of 7 carbons, and hence it is called heptane. Thereby, it will be coming out as 3 ethyl 5 methyl heptane. You will go for third option. Yeah. Immediately it is given 3 methyl 5 ethyl. This is option is also there. And if you directly write this also, that option is also there. Need to be careful. So this is IUPAC nomenclature. Simple question. Possibility of error is there, but it is okay. You can manage it. This is easy to moderate level of question. This one is straightforward. You are having Ma2B2 type of complex. Mostly platinum complexes are square planar in shape, and hence A2B2 means it will exhibit directly shape only. He is asking square planar complex. And this one is octahedral in shape. You can go by this. This is tetrahedral in shape. You can go by this. This one is a trigonal bipyramidal. Choose the answer as a fourth option. It is also a simplest question where people should not make any mistake. This is easy only. Name itself is suggesting when time t equal to 0, concentration is C naught, and as time progressing, the concentration is decreasing linearly, and hence you can write the concentration varies as C equal to C naught minus some KT. It is like slope is negative, intercept is positive. So you are aware, straight line equations you can find this C equal to C0 minus KT, or KT equal to C minus C0 by T. That means the order of the reaction is becoming 0 order reaction. Because K is nothing but what? This C0 minus C by T it will become. That means it is nothing but rate of reaction. So rate of reaction and rate constant are same, means the order of reaction is 0, and you can run for this option without any trouble. This is also somewhat easy. People may get carried away. This, if you take it as logarithmic concentration and time, you will go for first order reaction, you will go for second. So this is not easy. Trapping is there, and hence it is a moderate question dealing with the kinetics. Which one of the following is an ambident ligand? Ambident means it should have tendency to donate through donor atoms. So it is basically a monodentate ligand which has two donor atoms in this thiocyanate, most common example which we give. This is an example for a ambident ligand. It is nothing but in this manner you will have SC triple bond N thiocyanate ion. SCN minus will have sulfur donor, or if you write the resonance form, you can write S double bond C N minus. This can donate, and hence it is an example for ambident ligand. So you need to go for this fourth option. Consider the following reaction. I can say by looking into this itself, I will say this as a D. Sorry, difficult level of question, not the answer I am writing. This is a difficult question, right? The answer is 2 only. How you need to get? When we are talking about delta G naught, you need to go for delta G naught equal to delta H naught minus T delta S. And here you have delta H, but that fellow didn't give delta H directly. He has mentioned delta U. So when delta U is given, you need to calculate first delta H. These two are related by delta U plus delta N or T you are having. So delta U is in kilojoules. So this is becoming a minus 10 plus delta N. Here how many are there? 2 moles. Here 3 moles are there. So the change is minus 1 and hence minus 1. R value is 8.314. Remember, this is in kilojoules, this is in joules. So convert that into 10 power minus 3. And the temperature is given as 298 Kelvin, 298. So as soon as you see the calculation, you will leave the question and run away. I am very sure. If at all you are lucky, you will put one answer. Otherwise, you will just leave it after seeing the calculations. So that's why I graded it as difficult. Once you get this, then you need to go for delta G. That is nothing but delta H of this minus of T delta S. I am saying this is given as a 44. This will become minus of 44. And the temperature is given as this 298. If you do that calculations and simplify that, the value is turning out to be plus. Since it is becoming a plus, delta G is positive. Delta G is positive means reaction G is non-spontaneous. It is a non-spontaneous reaction which can happen only with some other assistance. Right? So this is a difficult question. And some people may think even there is no question to think, because the 2 options it is given as a positive, 1 option it is given as 2 options as a negative. If at all 3 plus and 1 minus, so odd man out we can select and put the answer. So this is a time taking problem, calculations involved. So the most difficult question in the entire paper is this only, I can say. So this is a difficult question. This is simplest one, ozone. Here it is having this O double bond O forming a normal number of bonds as it can form. So the formal charge on this is 0. It is forming more number of bonds than it can form. More number of bonds it is forming. So it is having 2, 1, 3 he is asking. In this case plus 1. And here it is having more number of electrons. 2, 4, 6 and 1 more 7. And hence it is a negative charge. And hence you can go by this. So 1, 2, 3, if you number it 1, 2, 3 like this or 1, 2, 3 like this, done. Though question looks simple, possibility of error is there and hence you go for moderate. So attentiveness in exam is more important than your preparation. Of course, preparation is also needed. At the same time, attentiveness in exam is also required. Exam temperament. Kp is not equal to Kc. Whenever Kp and Kc you are talking about, Kp equal to Kc into RT whole power delta N. You need to see delta N means number of gaseous products minus number of gaseous reactants only. So here if you look at 2, 2 here, 2, 2 here, and here if you look at 2, here also 2, and hence there is only 1 where Kp is not equal to Kc. So it is a simple question. Only if you know that Kp and Kc are related by this, Kp equal to Kc into RT whole power delta N. So given below is an expression for rate constant of a first order reaction. It is given as a ln K. So you can write it as ln K is equal to ln A minus Ea by RT you can say. So if you look at and make a comparison of the identical terms, if you look at 1.25 into 10 power 4 is nothing but EA by R. And he is asking the activation energy, expressing it in kilocalories. Remember, he has given it in calories and he is asking it in kilocalories. Thereby, EA value is nothing but 1.25 into 10 power 4 into 10 power minus 3 into 1.987. You can write. So if you simplify that value, that is turning out to be, that is how much value it is going to come. It is approximately 12 point, that means 4. This is 24.84. So it is a problem, direct application of Arrhenius equation. Ln K equal to Ln A minus EA by RT. Only trap is whether you are seeing the options perfectly, units carefully. He is asking it in kilocalories, but that fellow has given the value in calories. Just need to be careful and solve the question. Nothing else in this. This one is a straightforward question. Many people might have familiar. This is amide. As soon as you see amide and bromine NaOH, it is a Hofmann-Bromide reaction. Thereby, you are going to get a C2H5NH2, a primary amine. Chloroform KOH, it is nothing but isocyanate test. It will give rise to C2H5NC. Isocyanate is obtained. You want to prepare this Z as C2H5NC, and to get that, use silver cyanide. So you just need to go for this fourth option. So don't get carried away by first option, because the other one is gone. So this is a most commonly appearing named reaction. Many of the competitive exams it is coming, and hence this is somewhat easy only, but the trap is there with the silver cyanide and potassium cyanide. You need to be careful, you need to be clear what that ambident nucleophile can do in substitution reactions. Right? Yeah. Then this one is a somewhat easy question. NH3 twice Cl2. As I told, this is a square planar complex. Ma2, B2 type of complexes can exhibit a cis-trans isomerism, which you can call it as a geometrical. So this will match. And COE thrice, it is a bidentate ligand. Chelating ligands, if they are present, then they can exhibit optical isomerism. And if you are having NO2, this is a ambident nucleophile, can bind through nitrogen or oxygen. Here you can get linkage isomerism. And water, if it is present, based on the number of water molecules present inside coordination sphere and outside coordination sphere, if the difference arises, then that is called hydrate isomerism or solvate isomerism. You can go by this option. So if you go by that, the answer will become 3. This is also easy, and this is the coordination compounds, easiest question. I hope you enjoyed the discussion. I hope you got the key perfectly, and I wish you great success, and wanted to see you people scoring much higher marks, 600 and 650 plus marks, and getting success in all your examinations. Best wishes. Thank you, and look forward for your success.